Hello and welcome. I'm Andreas. I work as a trainer and consultant primarily for C++. And I'm also the creator of C++ Insights. And this is also the tool I like to talk about in this series. In this episode, I will explain what C++ Insights is and give you a little introduction in where you can find it and how you can easily use it. So in today's episode, I like to talk about a C++ 17 feature, which is called constexpr, but we write it if constexpr. In today's episode, I like to show you a C++ 17 feature called Class Template Argument Deduction, or short CTAD. And that brings class templates a bit closer to function templates because it gives us similar semantics. We no longer have to provide the type when we instantiate our class template. Here in line number 8, for example, the same way we can do it with function templates, because function templates always were able to deduce their argument types. In my case here, the myClass is a class template taking a single type named t parameter here, and it comes with a constructor using that t for two arguments t and u, taking them by const reference. Prior to C++ 17, I must specify which type I create this class for, so I say int here, and that of course works. In C++ 17, thanks to CTAD now, I can omit these specifications in that case, and I can simply transform that, and you see there's no real difference. So this code compiles because the compiler creates for us what's called an implicit deduction guide. So CTAD, Class Template Argument Deduction, uses so-called deduction guides, and under some circumstances the compiler is able to generate them implicitly for us. This you can see in C++ Insights. So line 26 to 28 here on the right, this is the compiler-generated implicit deduction guide. You can see it always starts as a template specialization, and then we can see this as hypothetically, if I have a function called myClass with two parameters t and u, which are of type int, then instantiate myClass with the parameter int. And this potential function here, that's the constructor. The compiler tries to construct myClass, and it hits the constructor, and it sees, I don't know what type t is of, and then it consults the deduction guide, says, hey, if I instantiate that function, can you say me how to instantiate the class then? And this is what this deduction guide provides. So it's guidance for the compiler. And below in line 32, we can see, it's now like before, we add in the angle brackets the type, or better, the compiler does that. This is a good way to reduce the code. You have to write a little. It's not always good to hide all this information, but in certain cases it is. So where does CTAD come in handy? Here I have an example. I create a stud vector v with the values 3, 4, and 5. Values don't matter. And pre C++ 17, I have to say that this is a vector of ints. But I did already say that because I have to initialize a list using curly braces, so that means also non-narrowing conversions, so that vector will be initialized with integers. Okay, and this is one case where in C++ 17 and later I prefer to omit the template parameter at this point. I can simply say that's a stud vector, and I know from the initializers that's a stud vector of int. So this is not really obfuscating or hiding information from me. Another example is stud array. Say I have a stud array, and it's a replacement for a regular C array. So in regular C arrays, we can simply say it's an array of type char or type int, let's say it's of type int, and then the compiler deduces the number of elements and it creates us an array only of this size. And prior to C++17 for std array, we have to say, oh, how many elements in there? Oh, 5. No, it's only 3 actually. So that makes refactoring complicated. 4 is also the wrong number, so 3 is the right one. Okay, that compiles, that's nice. But if you get closer to a regular C array, I want to have this feature at least. I don't want to have to say the size of this array. I set it on the right. So I want to get rid of this size parameter, but then once again, it's like with the std vector, I know which type the std array is of. It's of its initializers. I want to remove that as well, because all the information is there. It's 3 elements, they are of type int. So let's transform that, and we can now see that it happily compiles in C++17 and later. And on the right you can see it's a std array of int with the size 3. Ah, sure, the compiler knows that. And this is knowledge we can now use and use to our advantage and get rid of the need to specify it twice. But this is a feature where it depends a little on whether you like it or not, whether you need this information or whether you can see it on the right. So I would say this is something which you have to experience a little and test it and try it out, because initially it feels like, oh, we lost information there. But then if you think closer about it, it's not really the case, because the information is still there on the right. It's just looking at a different place, and some place where we may have earlier looked at to figure out, well, it's now 3 or 4 the right number. Oh, it's only 3 initializers, so the size of the array we should write 3. Give it a try and see how it feels. And of course, let me know. That's it for today. Stay tuned for the next episode. Bye bye.